Hello guys, welcome to this video. This one is a requested question from paper May-June 2003 of the transformation question. So answer the whole question on a sheet of graph paper. Okay, here we have the diagram shows a triangle A and the straight line y equal to x plus 4. This is the straight line given to you. Now triangle A has vertices 3, 2, 3, 4 and 4, 4. Okay, now part 1 is using a scale of 1 centimeter to represent 1 unit on each axis, draw on a sheet of graph paper the axis for the values x and y from this to this. So let's do that. So you have to get a piece of graph paper for that question. So let's first draw an axis for let's draw for y first. Y will be from -6 so -6 till 10, so that should be okay. So let's count. Here we have, let's say we start here. Let's say we start right here, so not too bad. This is -6. Okay, -6, -5, so we have to go until 10, so that will be 2, 3, 4, 5, 6, 7, 8, 9 and 10. That is your y-axis. Now for your x, you have to go from -6 to 6. This is your x, so 0, 1, 2, 6, and going to -6, -1, -2, -3, -4, -5 and -6. Okay, so first step is to draw this, and then we have to draw and label triangle A and the line y equal to x plus 1. So A is given to you by these points, so pretty easy. So 3, 2, we have the point 3, 4 and the point 4, 4. That's your triangle A. So let's connect all the points. Okay, and label this as your triangle A. And next we have to draw the line y equal to x plus 4. Has to go through the point, these 2 points, this and this point. Okay, so that's the line that we need to draw. Okay, that is question part 1, just 1 point. Now the next one is the transformation M is a reflection in the line, in this line, right? Now the transformation M maps triangle A onto triangle B, so that we have A going to B by transformation M. Draw and label triangle B. So pretty easy. It is only a reflection in this line, so we can go this way, right? And then we have to just count the squares in a horizontal fashion. So here we have 1 square, half, that will be half, and 1 square. That should be a new point. This one is, if you count 1, 2, 1, 2, should be right here. This one is 1, 2, half, half, 1, 2. Okay, so we have this as your image. So this one is pretty straightforward, and label this as your triangle B. Okay, that was part 1. Now next one is part C. Triangle C has vertices -1, 2, 1, 2 and 1, 1. So let's draw that first. Triangle C has vertices -1, 2. Then we have 1, 2. And then we have 1, 1. That is your triangle C. So draw and label this as your triangle C. Now let's see what is the question. It says the rotation R maps A onto C such that A is mapped onto C by rotation R. Part 1 is find the angle and the direction of this rotation. Part 2 is the coordinates of the center of rotation. So in that case, we can just use something here. The one thing we could do, it seems that rotation was in this direction, but let's use our tools so we can find exactly where is the center of rotation. So one thing we can do here is, instead of guessing, let's try to connect the corresponding points. So this point was, so let's do that. I will use a different color. So here I would say this point became this point, so I'll connect these two. And this point became this point, so I'll connect these two. Right. So next step is we have to draw the perpendicular bisector of those two lines. So for this point and this point, what is the perpendicular bisector? You would say it is half midpoint, so it will be like this. That is the perpendicular bisector of that line. Okay, so let's draw that. Now we have to find the perpendicular bisector of this line. So if you observe, it will be about, usually you have to use a compass, but here by observation you can see that this line has to go exactly halfway, will be right here at 90 degrees, so at right angle it should be in this fashion. Let me use a different color so you can see where they meet. Okay, so where the blue line meets the red line is your center of rotation. So here you can see they meet at 1, 4, that will be your center of rotation. Now you have to find the angle of rotation. So if you count, let's say, so this point became this point, so from this, so let's join them. This point became this point. So as you can see, the angle here is 90. So it means that the angle of rotation is 90 degrees and it is clockwise rotation. Right, so pretty easy. Let's write this down. So find the angle of rotation. So angle A is 90 degrees clockwise. Okay, and part 2, the coordinates of center we have found it was 1, 4. Okay, so now this one is just one of the methods you can use to find the center of rotation and also the angle of rotation. But you can always use matrix to find this as well. So matrix can be, we don't have space to do that, so it can be, you need some space, but this one is way faster in those questions. That is question part C. Now next one is, given that MR, so we have, this is the transformation R, transformation M, this is a triangle A. So you have to find D. So A is mapped onto D, first by rotation. Okay, so when you rotate when you rotate A, it is given to you here. So C is a rotation of, so rotation maps A onto C. So if you rotate A, you have C. Right, so this becomes C. Now matrix M by C, M is what? M is a reflection in this line. So we have to reflect C on the line. So C reflecting on this line will give you triangle D. So let's count. This point become half, half will be right here. This will be 1, half, half, 1. And this one is 1, 2, 1, 2. Okay, as you can see, this will be your triangle D. This is your triangle D. So just to explain, so what does this mean? It means that, let's say M, R, A equal to D. It means that first you have to rotate A by this transformation R. So you know that already. A has been mapped onto C by this rotation R. So it means that this becomes your point C. Now from this, now that your triangle C, so from this, you have to use transformation M. M is given to you by reflection, so you have to reflect the triangle C on this line to find your triangle D. So pretty easy. So once you have C, you know where C is, you just have to reflect on this line to find your triangle D. And that is your question number D. Now for part E is the matrix this represents a transformation N which maps A onto triangle E. Okay, first part is find the coordinates of the vertices of triangle E. So pretty easy in that case. As you guys know already, you can use matrix times object is equal to image. Matrix we know already, which is 1, minus 1, 0, 1. Now object is your triangle A. You know the points already has been given to you. So 3, 2, 3, 4, and 4, 4. So we just have to evaluate this to find the image of this matrix, right? So 1 times 3 is 3, plus 0 is 3. That will be 3 and 4. So this will be minus 3 plus 2. So minus 3 plus 2 will be minus 1. Minus 3 plus 4 is 1, and that will be 0. So this is your new image. Let's see where we have. So 3 minus 1. So 3 minus 1 will be right here. Then we have 3, 1. So 3, 1 will be right here. Then we have 4, 0 will be right here. Okay, so 3, 1, 3 minus 1, 4, 0. So let's join the points. So this is your triangle E. So don't forget to label this as your triangle E. So this is your triangle E, okay. Now part 2 is, as you can see, describe fully the transformation N. So we have to describe what is the transformation N. So if you observe what happened to A, you would say that A was, so in those cases, it cannot be stretched because it's not really stretched in any other way. So in that case, it has to be a shear factor, sorry. If you count, let's say from this point, so this point became, this was the point 3, 2, it became this point. So let's count, we have 1, 2, 3, it became 1, 2, and 3. So the factor of 1. And this one became 1, 2, 3, 1, 2, and 3. Okay, and this one is 1, 2, 3, 4, 1, 2, 3, and 4. So exactly, this one is a shear with shear factor equal to, so if it goes down, it has to be in the opposite direction, minus 1, and then the invariant line equal to the y-axis. Okay, so how do we find a shear? So how do you know it's a shear in this direction? Because usually stretch has to be stretched this way. We will see exactly how it is stretched. That is one of the reasons why. And then the shape is kind of it's kind of strange, right? You can always test to see what is this transformation. So to use invariance, to use the shear, we have to first count from this line. So we know this point became this point, right? That was the first, this point became this point. According to your transformation here, the first point became this point. So 3, 2 became 3, 1. So 3, 2 was this, 3, 1 is this. So let's look at those 2 points. Okay, so how do you count the shear factor? So first you have to count distance from the y-axis. So we count 1, 2, 3. Okay, and then this move to here, we have 1, 2, 3 as well. So 3 divided by 3, it means is 1. So the shear factor is not 1 because it goes down. In that case, it is minus 1. If it were to go up, it will be shear factor of 1. In that case, it goes down, it is -1. So we can test another point. So this point became this point. So this point became this point. So how do you count shear? You have to count from your y-axis. 1, 2, 3, and became, so we have 3 here. We have 1, 2, 3 as well. So 3 over 3. This 1. So it's still the same -1 because it goes down. So it means that we confirm that it is consistent with the scale factor. So in that case, we confirm this one is a shear. So by doing that 2 steps. Now, when we describe a shear, we have to provide the scale factor and also the invariant line. The invariant line is just a line from where we count from. So as you can see here, we count from this line and then we reflect in this direction or in whatever direction. So this line doesn't move, it's called the invariant line. We count from this line. So we have to write this down for your marks as well. So this is your 1 mark and this is your 2nd mark. You have to write both down for your 4 mark. Now for part 3 is write down the matrix that represent the transformation that maps E onto A. So as you guys know already, so we have this matrix. It was used to map A onto E. Now to map E onto A, we have to do what? We have to multiply by the inverse on both sides. So the matrix that multiply E onto A will be inverse of this matrix. So let's see how do you find inverse of that. So as always, let's have some space. The matrix was, so definitely we could write this directly, but if you don't know, you just have to find the inverse. So first you have to find the determinant, that is 1 minus 0, which is 1, and the adjoint matrix is 1, 1, 1, 0. So the A inverse, sorry, the matrix inverse will be 1 over determinant, so it will be this one. So this will be your answer for the matrix. Okay, so part 3, it is 1, 1, 0, 1. So I think I will have to do a video in the future about shear factor, stretch and all that stuff. But for now, I hope that was somewhat helpful. And if you guys have any other questions, leave a comment down below. As always, thank you for watching. I will see you soon.